So today we're going to learn about the basics of the serverless offerings of the three major providers, Google, Amazon, and Microsoft. Before I start, I want to do just like a little housekeeping, because we're going to be here for a while. So whether today's your first day or we're here Thursday and Friday, you're going to be learning a ton of cool things. And I want to make sure you don't want to spend my talk frantically taking notes and instead focus on laughing at all my jokes. So everything I'm covering today is going to be on my website, the slides, the repos, all the code samples, all on michellebrenner.com under the speaking tab, and you'll see my Twitter on every single slide so you don't forget. If you have any questions and you don't feel comfortable speaking up, feel free to just tweet at me. I'll answer there, or if I see it before the end of the talk, I'll let everyone enjoy the answer, but I won't give you away. So why do I want to give this talk? Being a self-taught engineer means your education is a little ad hoc. Most of the things I learned were from other people suggesting them or trying to solve a direct need on the job. Basically a just-in-time learner. When I was working more and more in the cloud, I realized most people aren't going to have the chance to work with different cloud providers. Changing cloud providers can be very difficult and not at all worth a company's time. And if you do get to choose a new provider on the next job, it's much easier to go with the one you're familiar with. Because despite all this documentation and demos and talks here today, cloud services have a steep learning curve. They all accomplish similar tasks, but with different terminology, design philosophies, and after today, I hope you have the knowledge and confidence to start creating your own projects, whichever cloud provider you decide on. So, why serverless? 10 years ago, I got an extremely practical degree in 3D animation. Luckily for me, I had some experience coding, so when a job came up to work in a tech department at a visual effects company, I jumped at it. Working in entertainment technology is very different than other large tech companies. Tech is not their business. Art is their business. Anything that will get the artist producing faster or higher quality images will be used. The work cycle is also not in sprints, quarters, years, but instead is counted in projects and film shots. So my first job was focused on reducing the company's biggest expenditure, artist time. And if you were working on a tool and it was not done fast enough to actually help on the project you were working on that year, it was totally useless. This taught me to be practical and put business needs first, not technology. I like serverless apps because they help me solve problems easier and faster. And finally, right before we dive into the tech, I want you to keep in mind my motto for this talk and basically every talk I've done. If you were one of the 5 people who saw my talk last year at Scale, I had the exact same motto up, which was, do less, accomplish more. I want you to learn how to use these tools so you can make great products but not work as hard. So what is serverless, if you haven't used it before? Serverless computing allows you to build and run applications and services without thinking about servers. This is a quote from AWS. I should attribute them. Serverless applications don't require you to provision, scale, and manage any servers. You can build them for nearly any type of application or backend service, and everything required to run and scale your application with high availability is handled for you. Of course, serverless has servers. It's just someone else has to worry about it. This is often also called function as a service, if you've heard that term. You provide the business logic. They take care of everything else. Sort of, but we'll get to that. So serverless works best in small, self-contained microservices. Each service should do exactly one thing, so you don't have to create complex interactions in each one. Instead, they all talk to each other to create larger features. As a quick example, let's talk about an e-commerce site, let's say Amazon, and its checkout page. When a customer is trying to check out, there are numerous questions that need to be answered to provide a checkout service. So here I am answering questions like, are the items available? What warehouses are they in to check shipping speeds? Are there promo codes to be checked? And what payments does the user have? Do they have a gift card? By separating each one of those questions into a different service, it means only the service needed is running at any given time. Remember, with a serverless app, the service spins up itself when needed. So if a user never enters a promo code, the promo service never has to come up. It also allows for independence. Internally, the services can do anything as long as the input and output contract stays the same. So when looking at this chart, it should remind you of a relational table or endpoints in a RESTful API. So just think about other things you might find on this page that could work as a standalone service. So what did I make in this talk? Keeping all those processes in mind, I wanted to create a template that we can use to make every single one of those services easier. I wanted an endpoint that allows you to add data to persistent storage, get that data, add that data, edit that data, and delete that data. Basically, I CRUD the service. I wanted to be able to test that endpoint, deploy updates, and have it secure. I want my template to define all the services I use, so if they get destroyed, if a raccoon eats my server, I can easily spin up everything again. So these are the questions I wanted to answer about each of the cloud providers. I not only wanted to answer them, but test them myself and save it in the repo. So what are each of the services needed to create my microservice? How do they work? Do they work well together? How fast can I get to coding? Because I just really want to code. How do I structure that code? And do they have good Quickstart tutorials? Is there capability for creating a template to describe the services and how they interact? Basically, programmatic infrastructure. How difficult is it to understand and create? And what were the roadblocks in understanding how that works? So I'm a big fan of test-driven development, and I like to get started right away. Until I start testing, everything I do is theoretical. The document can say one thing, but that function could do a totally different thing. So I wanted to answer, with testing, was I able to set up local endpoints and test them? How hard was it? Was I able to add unit tests? Was I able to actually mock the infrastructure to create true unit tests to make sure they were self-contained? And how hard was it to test real-world payloads so integration tests were as accurate as possible? Was I able to successfully deploy? As in, is there a URL I can give you today that returns the data I want? And then, is that endpoint secure? If I give you that URL, will you be able to access that without having a username and password? And can I limit how much people use it so I don't get, a DDoS attack from millions of people hitting that endpoint for fun that returns almost nothing in 1 second? And then how do I secure the services between each other and limit who can update the services so not every engineer will break my service? And then how hard is it to figure out when something is going wrong? So don't panic, but maybe a little bit, because not to discourage you, my first lesson with all of these services is they were harder than they looked. Setting up a quick example in the UI is fairly straightforward, even though the wizards have a bunch of checkboxes that don't make any sense. But it's really just a matter of filling in forms, deciding on names, following through on the tutorials. But even then, it doesn't always work. Setting the app in a sustainable way so it could be production ready is much more difficult. There are a myriad of options in everything you do. Error messaging can be obtuse. Every error message could be a timeout error, no matter what the error is. But hopefully, you're a little sympathetic as an engineer that has tried to write an error message for someone to understand. But I'm telling you this so you persevere. There's a steep learning curve, but sustaining and scaling the system makes it worth it. It's really hard at first, but you'll get there. And what I'll go over today won't give you all the answers, but at least give you a step up. And here's a working system. Let's add to it. Okay, So my approach for figuring out what services started with the core, knowing I wanted to store data for an item. I asked myself, what's the easiest way to store an item with an attribute for each service? What's the serverless tool to access the data? And how do I create an endpoint for that service? These are what I decided on. So for AWS, I use API Gateway, Lambda, and DynamoDB. API Gateway is a dedicated service to creating the routing. Lambda is a function where it parses the request and accesses the database via an SDK. DynamoDB is a non-relational document storage. I chose that database because it was the best integrated with the serverless services on AWS. If you're used to relational or SQL, you have to be careful with this because it can quickly get messy. But with a one-pass microservice, it tends to not get that complex, so it kind of takes care of that problem. And I tried setting up a MySQL database with Aurora with serverless, and it was super hard and not worth it at all. So when I just need a single table, DynamoDB is much easier to connect. For Azure, I use HTTP Trigger, Azure Function, and CosmoDB. You'll notice Azure named its function to represent what it is, a function, which is like major points in its favor that you actually name something, what it actually is. So I also want to point out the entry point to a function is not another service. It's not like API Gateway. Instead, Azure has this concept called triggers and binding. A trigger is anything that can call a function. In this case, I'm using an HTTP trigger, which will handle the routing. But you can have other triggers like logs and things like that. A file landing in storage, a row changing in the database. And then a binding is the output of the function. In this case, the binding is going to Cosmos DB. That data store is flexible and holds a variety of collections. But I use it as a table and accessed via SQL queries. I chose CosmoDB because it was built-in recommended service for functions. So I hope you're starting to notice a trend where it's like, whatever the cloud provider told me to do, I was like, this is what I'm going to do because you promised this would be the easiest way to do this. I mean, it wasn't, but whatever. For Google Cloud, I use the same HTTP trigger. It's like they talk to each other. Cloud Function and Cloud Firestore. They also get a point for naming the function. They get negative points because there's a combination of documentation that can make it confusing to work with. So App Engine and Cloud Function are two different things, and sometimes if you look up Cloud Function, you get the documentation for App Engine and vice versa. So that's confusing, and I've complained to them, and they haven't fixed it yet. So it took me a while to realize there were two different services that did slightly similar things. And there's more information in the README and the repo. But the basics is that Cloud Function is a simpler version of App Engine, which is why I went with it. Cloud Functions also have the same triggers like Azure. It can be other services, but it doesn't use the whole binding concept for output. Instead, the function accesses a database via an SDK like AWS. Google also doesn't use its own routing like Azure AWS. Instead, it used Flask, common Python framework. Actually, I don't know if I mentioned, but I did all of this in Python because that was my first language, and I thought that would be the easiest. But they have support for a bunch of different languages. So if you're used to using Flask, this is great because you already know how to use it. It also means the routing is tightly tied with the language and the function instead of decoupled like API Gateway. In practice, it did not make a huge difference. But if you're using multiple languages on different services, it could be annoying to define routes in different ways instead of, say, one YAML or JSON file. So let's talk about Quickstart. If you're anything like me, you want to code as fast as possible. You just want to get this done and see it working. So deciding on folder structure, typing out config files, not fun at all. So I want to test each provider on how fast I got from starting to writing code. A nice feature of all three of the providers is the ability to try things out in the UI before you have to create your repo. This is the best way to start because you can see how the services connect, get things launched, and play around without having to worry about syntax. It's definitely possible to make an entire project that can be used But then you're not using the source control or IDEs that make collaboration easier. So I made a fresh repo in GitHub and got started. For AWS, I use SAM. SAM is a multi-use open source tool. For this section, doing a SAM init does the initial directory setup and includes a sample hello world, which is nice. It also includes a README that doubles as the tutorial for setting up your serverless function. I was able to go into the app.py and start working pretty much right away. I only started running into trouble when I had to add a library. I just wanted to use simple JSON to make JSON easier, and somehow this is very difficult. But I eventually, pushed through. So for authentication to my AWS account, I had to set up a config file on a profile because I have multiple AWS accounts on my machine. And then I set the profile as an environment variable. I set all the secrets and configuration as environment variables. It wasn't built in, so I had to handle storing and deploying those environment variables myself so that when the function was in AWS, it could find all those variables. One interesting step is that I had to confirm my identity via a phone call, which took a few hours to get to me. I was super confused why nothing on my new AWS account wasn't working right. And that's when I realized that there was a freeze and they needed to confirm my identity by calling me. So just be on the lookout if you start a new AWS account and just nothing works. There's no messaging for that. You just wait a couple hours. So for Azure, I use a program called Func, F-U-N-C. It's kind of an all-purpose tool like SAM that has an init that sets everything up. It was straightforward, walks you through setting up your first project. One warning is that all the initial installations can take a very long time. So I would start the installation hours before you want to work. I was like, I'll do a Quickstart for 2 hours, and then 3 hours went by and I hadn't finished installing. And then it was all done. It was much faster. So I used the create an HTTP triggered function in Azure tutorial, and everything pretty much worked. The actual Python is a little tricky because it had some formatting that looks more like Java. But once you understand the trigger binding dynamic, it makes more sense. And if you know Java, you'll be like, oh, this looks very familiar. The authentication uses a shell script that redirects to the website. So the first time configuration setup was really easy. And I'm sure it's storing something on my machine, but it was neat that it handled it for me, and I didn't have to worry about where do I put my config file, how do I store this securely. Another nicely handled feature is local settings. By default, it's already in your project, so you can see where to put your environment variables and have them automatically available in the function. And anything you put in there is available as part of deployment, like your database name and your function. And when you deploy manually, just to specify, make sure those local settings go with my function. So it was nicely set up for you. So for Google, there wasn't a single tool like SAM or Func that just automatically got me up and running. Instead, I had to look through a bunch of tutorials to try to figure out what was going on. I started with going through the UI, and then I realized I could download the function from the UI and see what it looked like. So it did not include a configuration file, so when I wanted to deploy it, and I'll talk about more in the next section about deployment. In the meantime, they do have a Python samples repo, which was super helpful on how to set up and test those functions. So instead of launching a local instance like the other providers, I tested with the built-in Flask tools, which was nice. And then for the authentication to the Google service, I set up a key, then downloaded a JSON file that I added to my environment settings. For other environment settings, it's similar to AWS, where it goes in the config file, or you store in their version of secure storage called NDB, which is stored in the data store. So let's talk about describing that infrastructure. In any cloud service, you'll want to programmatically define the infrastructure as much as possible. That means all the configuration for the app is written out. It can be stored in version control with the code. For example, Amazon uses a tool called CloudFormation. CloudFormation reads either YAML or JSON. And in that file, you can say, I want to make a DynamoDB table, call it this, make this the key, that sort of thing. So say you want an index or change something about the database setup. If you do it in the console, it's not as easily trackable. If someone wants to know what you did, they could try to puzzle it out, but it's an investigation. Instead, you'll change your CloudFormation file, commit it to a repository, then have Amazon read and deploy your changes. This not only documents the changes, but allows for multiple environments and emergency recovery. For a professional level project, you'll want at least one staging environment to test things out before you release to productions and break everything for all your clients. By having this config file, you can make as many versions of your setup as you want with different names. So I had some fun with this. I was like, how many can I make? I made Michelle, I made apples, I made a whole bunch of them just to see how easy it would be, and it was really great. So let's talk about AWS a little more. So there is that tool called CloudFormation, which you may have heard of, or something like Terraform. But for serverless, there's actually a slightly easier way. That SAM tool I use for init includes a template file you can use. It helps with things like connecting to service and creating all the needed permissions and roles. Upon deploy, SAM converts that template file into a CloudFormation document. So it all goes back to CloudFormation, but SAM is a nice helper tool that you have to learn even less syntax to use. It does not provide all the functionality you might need, but just the basic stuff, and then you could slowly add in CloudFormation syntax if you need more complicated tools. And then every AWS service is kind of built to be separate, so you have to make sure you define everything and all the connections between them, which will get a little more complicated once we start talking about permissions. For an Azure function, you're not going to need a dedicated tool. Instead, you have a JSON file. When you initialize, it's created for you with an HTTP trigger and HTTP binding out. I added in a CosmoDB binding, so my data goes there for the post. And then there's just another file for the local settings. If you add settings in there, the function.json file, the main function file, can find it, as well as the function itself. When you deploy, there's a flag to make sure that parameters go with it. I found this, again, to be a very helpful feature. For the Google functions, there's not a config file. If you see any references in the documentation to app.yaml, that is a trick. That is App Engine. That took me a while to figure out. The only connection to another tool is through the SDK inside the function. So if you need something more complex than what's provided, that's when you might want to think about using App Engine. So one feature all the providers had in common was OpenAPI. You might know this as Swagger. This is what you'll want to use to design your APIs. It lets you define endpoints, their in and outs, security. This is especially crucial for all the databases I picked because it helps with payload validation. Since they all thankfully use the same thing, there's really no comparison here, but it's super good to know in case you want to try moving your endpoints over to another system. Use OpenAPI. We're getting there. We're like halfway through. So now that I know where the code was going to go, I wanted to do some testing, especially when I'm working with brand new tools. Setting up tests helps me go through the debugger and say, hey, what's actually happening here? So I want to evaluate different scenarios kind of on the spot. For AWS and Azure, the unit tests are fairly similar to other Python projects I've done in the past. For any outside calls, like calls to the database, I mocked it because we don't want to actually call in my real database. And it's not very clear that it's doing that until like you run a test and you go check in Amazon and you're like, oh, it actually added a bunch of test fields in there. So just be careful that you know what the function is actually doing and mock any outside calls. And if you want to have a test where it actually calls a database, make sure to use different environments so different people aren't hitting the same database and confusing each other. For Amazon, I was able to get the example payloads from the UI. They had a lot of examples there. If you go to the Lambda, there's a kind of a create test section. And then you scroll to API Gateway, because there's so many ways to use Lambda. And they have a sample payload that I just copied and pasted and mocked up my calls on. For Azure, I just used the debugger, and I just played around with the functions, so I was able to get a mock request set up, which was actually easier than taking the samples. It actually went a lot faster because I could see what it was actually doing, so that was nice. For integration tests, I wanted to get a local version of the API up and running, and then use curl or Postman to hit those endpoints. Amazon and Azure have those SAM and func tools that we've already used a couple times. But Amazon has an extra step. So you have to build the app. Building the app means putting the executable file and the dependencies in a hidden directory. Then SAM runs the gateway from there. This is critical to know because SAM actually says in its output, no need to reload the code when you make changes. But that's totally a trick because if you make any changes like, say, adding the simple JSON library that you thought was going to be super simple, it's like, I can't find it. You didn't put it in your build. And I'm just like, this is not Java. It's Python. Why is this so hard? You have to like edit this hidden file. It's really annoying. So you have to be careful to copy any changes you made to the original file. Otherwise, if you want to like quickly edit, you have to edit the like file in the build, and then you can iterate a little faster. But just be careful because when you rebuild, you'll lose it. And the IDE I use, PyCharm, has some like built-in stuff to help you build easier. But I wouldn't rely on that because you never know what IDE you're going to have to use. And also, just so you know the steps that are happening, I actually wrote a little shell script to help me with this so I could kind of follow along all the stupid steps it made me do for rebuilding. For Azure, there was no build step, and it automatically handled my new simple JSON package and pulled in all the new code. Much faster. So once I had them all up and running, I treated the endpoints. They were like a third-party API and did a request. I let the localhost run and then save the output using VCR. VCR is a Python library that blocks requests as long as the parameters are the same so that I could actually write and save the test, but no, I didn't have to calling out all the time. For example, in the Azure repository, I have a test to get on a localhost. I did it once, saved the output, and now when I do it again, it runs the same cache result. And then if a change is made, you'll see that it'll just say like cache failed, and you're like, oh, something changed here. Let me test it again locally to make sure it works. Those are my integration tests. And I'm sure there's other languages that have similar libraries of making sure you're not always calling out the third-party APIs. So for Google, it's just a Flask app. So I use the examples I found in the Google Cloud Python sample repo, and it was pretty simple to create unit and integration tests that used PyTest. And I was like, oh, this is my old friend. Thank you. So all of them suffered from poor error messaging while doing integration tests of one degree or another. This is one I mentioned before, but Amazon has a really good one where it just says times out no matter what the error is, without telling you what took so long or why. But eventually, just tried them over and over again until I got them through. So now we've got some code working and tested. It's time to deploy. First step is I just tried deploying manually. I wanted to make sure all the steps would run, and what options there were for automation. Amazon and Azure use the same thing we've been using over and over again, SAM and Func, to package and deploy the applications. For Amazon, the first thing you want to know is even if you're using SAM and not CloudFormation directly, you're deploying a CloudFormation stack. When you do want to find the deployment log, that's the service you go to. You can pull them in via the command line, but it's much easier to read in the UI, surprisingly. The problem will be in the middle somewhere because the top of the log shows the rollback of everything that succeeded. So it's kind of like succeeds, 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 fails here, then puts out a whole bunch of more log messages that it tried to delete everything you tried to do. So somewhere in the middle, something fails, and you just have to go find it. So if you fail to deploy repeatedly, don't get too discouraged. It takes a while to interpret the errors and connect all the pieces correctly. So when I finally got the CloudFormation stack deployed, but it didn't 100% work, there were some bugs, and I just found that through Googling the answers. So it's just a weird problem where the API gateway sometimes can't find the Lambda, and you just tell it reconnect, and it will. But once I did that, I was able to test it, and it worked. And one other thing to note about this is that if you make things outside of the stack, so say you manually made something in a service and you want to connect it, it gets like super confused. For example, I created a secret manually, so I was like, well, I'm not going to create a secret via my repo. I'm not putting my passwords in there. And then the CloudFormation stack said, oh, sorry, the secret already exists. I can't find it or control it, so I'm just going to crap out. So I had to work around that by making a secret that had no data in it. So the value was empty, and then I manually put in the secret later, and then CloudFormation stack to find it. So it's just a matter of knowing if you're going to use a CloudFormation stack, which I recommend, that or Terraform, then just put everything in there. Don't try to make things outside of it because it gets confused. And then I want to try automating the deploy. The recommended tool is a connection between Code Pipeline and GitHub. I made a hook, so when I merge to a specific branch, the Code Pipeline kicks off. The pipeline I set up does all the copy and deploy that I was doing manually that I found very annoying, and also just a series of commands. So I was able to add features like automatically running the tests, doing code quality checks, and linting. And it can also be used to update different environments by using a different branch with different variables. So it's really nice to be like, the Michelle branch makes a Michelle environment so that I can do whatever I want and test it as much as I want, and then the master branch actually makes the master environment. For Azure, you deploy using that Func app again. A warning here that logging is not automatically set up when you use Azure and functions. As of this moment, I haven't figured out a way to add it to the config, so I had to do it manually. It's called Application Insights, and you subscribe and then connect your function. There's also a 5-minute delay, so when I started testing the endpoint and got nothing that logs, I thought I had set it up wrong for a solid 5 minutes, but I just needed time to turn the logging on. When you deploy using Func, it gives you your new endpoint on Azure to try out, which was great. It just like printed it out and was like, here you go. So I was able to quickly create Postman tests, and then I noticed that the Azure SDKs were not included in the pre-installed packages. Like, Amazon knows to include Bodo, because like, why would you be using Amazon with Python and not include their main Python SDK? But Azure is like, oh, you're using Azure? I don't know if you need Azure SDKs. Like, of course you do. So I got some errors trying to figure it out, and then I submitted a ticket about it to try to learn more. And then it slowly made me realize more about what I was doing was that Python functions are in preview mode, so some stuff might not work. So I'll talk about it a little more later, but it's just kind of like running into walls because they're so new. To automate the deployment, I use Azure DevOps. It's kind of a similar style as Amazon. You connect your branch from GitHub, and it launches every time the branch is deployed. Then you have to create two different things, a pipeline and a release. The pipeline is where you put things like the Python versions, the tests, and those code quality tests. You also create the artifact for the release. I found a template for this and used that. I created a new release, and this is another place where I had trouble. The whole section was confusing. I used the same simplification that Func command provided me. And I wish I could use that. Func knows I want to deploy my application. Release wants me to set a whole bunch of settings that aren't very clear, and I just have to click through trying over and over again until I figured out what this was actually doing. So the automated deploy made me miss the manual deploy, which was much easier. That's like sad. For Google, first I had to mirror my repo into their cloud source repo. And then any changes I made to GitHub were reflected there. There might be a way to connect them more directly, but that was what they recommended doing. I don't know if they just like tricked me into putting my code in Google. And then I made something called a cloud build YAML file. Most of the documentation talks about Docker artifacts, but you just need the correct format for cloud functions. You can test the build using the command line, and it took, at first I was like, oh, this is so much easier than Azure DevOps. I just run it. But then it took a bunch of time to succeed because the service count that runs the build did not have the correct permissions, which is just like so frustrating. So why isn't there a button to just add the correct permissions? I don't know. That would just be easy, and it's not there. But it was fun because the error message was like, you have a problem here. Run this on the command line, and it'll fix your problem. And then you run on the command line, and it says syntax error, and you're like, ah. Oh. It was like so close to being useful. Eventually, I just like made it in the UI and was able to eventually figure out the syntax from doing that. And I was just like, you had such a good idea. But I'll talk a little more about permissions because it's just never easy. But after that little snafu, I set up a trigger for automated deploy. And then it was like almost anticlimactic how easy this was. It had some nice custom features I didn't see in the other providers, like the ability to trigger on a certain file in a certain branch, which was nice. So let's talk a little bit about security, our favorite topic. As of now, I've been making an API that anyone can access, but we'll want to limit that. Whether this be a public API or a bunch of internal services, you want to make sure you can control who accesses it and when. You don't want to allow unlimited access even from internal services because you could have a domino effect of failure. If one service goes haywire, you want to do as much as possible as you can to limit it to that single service. It also helps for compliance to limit data access. If you do something like PCI or healthcare, it's really nice. And then finally, you can limit developer access to change the infrastructure. They can change the code as much as they want, but maybe not add a bunch of databases and mess it all up. Don't let me mess it all up. For Amazon, there's a few different ways you can go. For internal service-to-service security and developer access, I used their IAM tool. If you're unfamiliar with IAM, first, I'm sorry for what you're about to go through. It's an extremely granular permission system, which is great for when you understand every detail of your system and like every touch point, but like incredibly frustrating when you just want one tool to access another, like Lambda, talk to database. Why is this taking 3 hours? I can't figure it out. So my method is to create roles with literally every permission until it works, and then slowly remove one permission at a time until it still works. Or, yeah, until it stops working, and then I'm like, oh, that was the last permission I need to get rid of. I don't know how to make, I mean, if you have tricks on how to make this easier, that would be great, but like, I think just over time, you start to like understand the permissions you need, and you set it up easier, but until then, it's just like, it's the worst. Yeah, so then I locked in my service. So another option is to generate API keys and share them throughout the services. This is basically like the brute force method instead of spending hours doing it correctly with IAM. But it does get you going really fast, and you can use Secrets Manager to store and rotate the keys, and they'll be encrypted. You have to then create a special authorizer service to check the keys so you don't have to rewrite the same logic for a bunch of services instead of that being built in, because why would you build in a thing to use your two services that you already built together? That would just be helpful. And then after you've done all that, you're like, well, maybe I should just figure out how IAM works, and then you just go in this like loop. But it's good to know that that option is there if you want to do like just a quick security check and put a key in. So there's also the user security. So it's a public-facing API. You could use the same API key method I already described as well. But what I really liked was using AWS Cognito. Cognito lets you set up user pools with different permissions and automatically assign users as they sign up. It also integrates all the social media logins for you, so like Google and Facebook. And that was a big selling point for me because I hate personally making new logins and always want Google to log in for me, even though I know that means they have all my data. For Azure, the security features are all similar design. The public security tool that includes social media login is Azure App Service. One thing to note is that it's in preview mode, kind of like using Python. Actually, I wrote this a couple months ago. Maybe it's out. That would be awesome. So in the Azure version of Secrets Manager, it's called Key Vault, which you can use to add and access API keys. It does not currently have an automated rotation tool, so you want to do that on your own. There's also the ability to create the same user and system identity to limit access, which is similar to IAM. And there's also something called Claims Principle, which I did not dig into because it was currently only available for .NET, and it looked really promising, but I was like, I'm not learning another language for this presentation. For Google, there are 3 areas to secure using the same tools. The 3 areas, again, are service-to-service, developer access, and user access. This is accomplished via a combination of IAM and OAuth. There's also a tool called Firebase that lets you do the social media authentication. And OAuth is basically a way of letting the user log in and agree to the permissions you've asked for. So you've seen this in action when you use mobile apps. It's almost always using OAuth. Luckily for us, Java makes this as easy as possible. I didn't need to set up any webhooks or custom code. You designate an OAuth code for the application, and then it was literally like copy and paste this JavaScript it generated for you. I just love a good copy-paste installation. So one question that comes up with serverless functions is, how do I know it's running? With a traditional server, you can have a ping letting you know, hey, I'm still here. With serverless architecture, it should only be running when you're computing. So that doesn't really work. It's important that you write your code and set up your services in a way that you know if something has gone wrong. All the providers have logging tools, but you have to make sure they're turned on. I mentioned that with Azure. And at first I was like confused because I was like, who doesn't want logging? You obviously need logging. But then I was like, oh, I guess the cloud providers are all just Spirit Airline, where, you know, they get a bad rap, but I kind of like them. You get what you pay for and not a cent more. Like, you just have to turn on every single thing and agree to pay for it. And they won't secretly charge you for things you didn't ask for. So you don't want to be charged for logging. Great, it's not turned on, but like, I don't know how you're doing any work. Once you turn on, you can see what's going on. So for this portion, I recommend thinking about the tools you already like to use for alerting and debugging and plug those in. I personally like Sentry, so I use that for all like the error logging. And you can set up all sorts of rules and alerts within the provider itself to give you more information. I have not taken any of these apps to scale, so this is definitely an area of more research of what logging methods are the best. Google Bonus Point's the only one who turned on logging by default, and it's pretty clear what's happening. It also has this cool feature where when you do a Python just like print command, it goes to the logs, so you don't have to remember the formatting for logging. So if you want to just do a quick start and not have to worry about defining a logger, you can just use print, which was like, of course. So one thing I like to do with this section is tell you how much the app will cost you between providers. But sometimes your abstract is too aspirational. My current cost for all these projects is $0. Since I'm only testing and have low throughput, I'm still in the free tiers. Putting my credit card was scary for all three of these applications. But the first thing I did was put in billing alerts. So if I spent more than $5, it would send me an email, and I didn't leave something accidentally running. And I've done a bunch of calculations for stuff I've done on the job, and it was pretty cheap. As long as you're not scaling incredibly high, if you have an application that doesn't need to be running all the time, this will probably be cheaper. Serverless will probably be cheaper for you. So I'm going to get into that a little more. So if you want to estimate your project, they all have, the services will tell you to the minute detail what things will cost, but it's kind of difficult to figure out adding them all up, because each service costs you something, right? Like calling the endpoint costs you something, calling the database costs you something, like everything adds up. So there are other services that will let you put in your application and tell you, kind of give you an estimate. But just think about if there's a way to not call services as much, you should do it. For example, if you're calling secrets to get a key, maybe you cache that key so you don't call it over and over again, because each time it costs you something. And it costs you something as in like a penny, but if you have a giant service, it'll add up. So it always adds up. So one thing to keep in mind as well is that all these services are invested in your success, because the more you use their service, the more money you both make. So if you are starting a business or starting a big project and you want to scale, it never hurts to contact them and see what credits they have available to you and say, hey, I'm going to start my business. Because they know they have you like locked in once you start using them, so see what they can get you. Speaking of reaching out, I tried support with all of them. In order to learn and make what you need, you want to use a variety of resources. The first step is I use the provider documentation itself. They generally have some quick start guides for the services you want to try out. But in general, they tend to suffer from explaining every flag of every function, but not actually explaining, I want to make a CRUD endpoint, what do I do? So that's where you might want to find other things like this presentation or blog posts. I found the most helpful because people would say, I have this problem, this is how I fixed it. So it can be like a little maddening in the beginning, but there are a lot of resources. So when I couldn't find the tutorials I want, I went directly to the providers. This is where I was kind of let down. I asked on Twitter, I asked on forums, I put in tickets, I asked on public Slack channels, not a lot of traction. This is definitely an area where the providers can do better about answering questions quickly. You can kind of lose all momentum when you can't get an answer on an error in 2 weeks. So it can be important to find others who are working on similar projects, either going in social media or in-person meetups or Slacks, which I already talked about. But if anyone has good Slacks for any of these, I would love to hear it, because the ones I went to were like super quiet and no one answered any of my questions. The one bright spot of support was Google. I put them with a ticket with them, and they got back with me in like 24 hours, and they were like, oh, because you're new, we'll give you like free support for a little while until you figure things out. And I was like, genius. Now I can actually use your system. So that was really nice. And I mentioned this a little before, that the IDE integrations are pretty good. I love using PyCharm and everything JetBrains does. They should give me a little money for this endorsement, just like Sentry, but what are you going to do? So the integrations are pretty good, but like I said, they're not perfect, and it's better to kind of understand all the parts that are running. So I definitely try everything out first with a command line and make sure you know what you're doing before relying on that integration. Ooh, we're almost done. I hope everyone's still awake. We lost a few people, but the rest of you all stayed, so I'm very excited. Most of us are still here. So this has been, I hope you've enjoyed this epic journey. I know I went really fast, but it's really just like touch points and like everything spelled out in the readmes on these repos. So if you're like, I don't remember what that was called or how to use it, just like copy and paste the code. I already put it there for you. Come to some conclusions, but I don't want you to take this as like dogma. The services are improving all the time. Like I said, there was like Azure was in beta mode for things, but I mean that can't last forever. So my goal is instead to give you a framework for deciding for yourself, and then also like skip some of the hard stuff that I figured out, and just start with my template and then move on, and then run it to your own hard stuff, and then you can complain to me about those. I'd be like, I can't do anything about it. So just a reminder what I talked about. The questions I want to answer. So what are the services? How fast can I get started? How do I programmatically define the infrastructure? That's such a hard word. How do I test everything? How is there a CI/CD deployment pipeline? How do I secure it? And how do I see what's going on? So as you heard, I was able to answer all these questions for all the services. They share some of the design patterns and architecture, but they implement it in different ways. So how to define which to use? I'll start with some technical questions. What language are you using? I use Python because that's what I was most familiar with, but if you're using .NET, use Azure. Go to the provider and see how many examples in the language you want to use, see if it's in beta, how many services support it. That's probably the right one. And like I said, if you are comfortable with risk and things not working, maybe use beta, and then you can give them feedback and tell them how to work on it better. That's nice of you. It's just harder. Talk about some angles. How do you want to use it? Do you work at a company and want to test the waters with a serverless microservice? And the answer is use whatever provider they already use. I found when trying to convince a team or a boss to adopt a new thing, it's best if it's like only one thing, like, oh, you're already using Google, use the Google function, You want to submit a pull request with 5 new features, so don't try to convince your CTO to use a new provider and a new architecture because they'll just ignore you. Are you looking to grow your skills to be more marketable? Look at the companies you're interested in and working for and see what they're using. Like, hey, I want to work for Salesforce. What architecture are they using? Learn that one. AWS is the biggest market share, so the company uses a different provider, you'll be even more in demand. Like, if they're using Google and there's not as many Google Cloud engineers, great, you'll get that job faster. And then also, if you want to work for one of those 3 companies, obviously, like, use their tools. If you're looking to create a new business, I would contact each of them and then play them off against each other. Who will give me the most credit? And then if you're looking to grow your skills for fun, then I say use Azure because their developer advocates are the most fun and because Microsoft is always the unexpected choice for fun. So just some quick final thoughts. I can't believe I got this in under an hour. I have way too many slides. Amazon, even though they don't say anything, Amazon is the original cloud provider, and it shows. They have so many tools, and it's used by most of the marketplace. But in the fast-moving tech, they can also be a downside. The other providers were able to see how they worked and do better things. Azure has a cool design. I really liked it. And the whole concept of trigger and bindings was once I understood it, it was just really interesting. And had the easiest Quickstart and all that, but it's beta for Python, so I haven't even got my app to completely work. Google used Flask instead of its own Raleigh system, which was nice to see because it was a familiar tool to anyone who's already made RESTful APIs with Python. That error messaging was just such a mean thing, But the fact that I actually got a response to my ticket was just like super nice. And their documentation was also outlined with similar sections that I used here, like monitoring deployment. So it's like we almost had like, oh, you knew what I wanted to do. It's nice. So it can be very easy to get overwhelmed by all the cloud offerings. This talk was like way more difficult to work on than I like originally had the idea. I don't want you to have like 50 tabs of documentation open and think you'll never understand this. You will. You'll get this. I promise it'll eventually work. I found that most of the documentation is very detailed on every single feature, but not great on that user story. So you'll get through it. Yeah. So this took me about like 80 hours to do 3 tiny CRUD functions. So just keep in mind how long it can take to like start up, but eventually with scaling it'll be very helpful for you. And then hopefully over time, the more I talk about it, other people talk about it, and these companies mature, it'll get easier. So here's all my repos. My GitHub is almost my Twitter handle, like so close. I should have just made it the same. But this is all on my website, so you don't have to you can take a picture, but you don't have to. I see the font decided to do it at once, so it's hard to read. So if anyone has any questions about them, feel free to reach out. And we have somehow 8 minutes left, so if anyone has any questions, feel free to ask them. I'm just going to go to the last slide so this stays up the longest, because this is my podcast. So if for somehow you're not totally sick of hearing me talk, I host a podcast called From the Source, where I interview people in tech and ask them what their jobs are really like, both the good, the bad, and the boring. And it's mostly them talking. So if you're totally sick of me, it's okay. Other cool people are talking. Thank you. Okay, it looks like we have a question. What's up? Yeah.
But what we found over the years is that, with SAM, just as I was describing earlier, there are these ports that you kind of have to overcome from time to time. So this year, what we're trying to do is move some services to serverless kernel, which I think is the layer that sits on top of some of these cloud providers.
Yeah. Yeah. Sure.
Have you ever tried
Yeah. So he's talking about using other tools that kind of sit on top of these cloud provider tools and help you do things. So like someone went through and did what I did and was like, this is all annoying, and then created like another tool that helped it make it easier. So I haven't used them that much. I really wanted to just use their offerings and see if they could give it to me. But that's great. Like if there's companies that can give you that service and it works for you, make your life easier. The only issue I have with that, and like I tried out like Terraform a little bit, and I found that like if you want help, you have to use the tools they have, right? Like when trying to debug CloudFormation, it was a lot easier because they're like, this is our tool, so I just like bug them a lot. But when you're using something that's like a layer on top of their tool, unless that layer has a really good service department that you're paying for, you're not going to get as much information. So it's like, it's like 6 one, half dozen the other. If the service is really great and helps you get started faster, an example is like Chalice is another Python library that helps you get started faster. But then when you run into problems, you're just like, you don't understand, you don't have like the whole framework in your head, so it's harder to figure out where those little minute syntax errors are. And the answers are usually not towards that package you're using, but towards just the base layer. So it's unfortunate, but yeah, I hope that answers your question. What's up?
Question. I know you said AWS IAM is very difficult.
Yeah.
How about your study or research? I want to know which cloud provider that you think has your academic security.
Oh, yeah. So you probably know more than me, but so my perspective is they all have secure things. You just have to use them. Like, there's a lot of security tools, and it's easy to just, like, not turn them on. But if you turn them on, you should be fine. Like, most of the times I've seen security issues when people just didn't turn on encryption or didn't turn on, you know, the login. But they all have tools that are available for you to do that. So that's less than, like, the comparison from one to the other. It's more just about not forgetting about security and making sure that's, like, part of your app planning. Like, that's why I put it in here, because it's not an afterthought. It should be integrated in with everything. And things like encryption, I used AWS. I did a bunch of stuff in AWS encryption, and it was just so easy. Like, you just make a key, and it's like 2 lines in Python. You know, it was just really great the way they handled all the complex parts of it. So it was just more about making sure you add it in. So, yeah, the question was about logging. So as I mentioned, everything is logged if you turn it on. So it's kind of on you to make sure everything is logged. And then the logging is helpful, and it's easy to understand what's going on. That's all on you. Like, they give you the tools to log it. And then I did a bunch of research, too, on, like, third-party logging tools. And there's definitely some better stuff out there, but at least you will have the stuff in the service so you can look at it. But sometimes it can be hard to parse. So that's where I would definitely, I think, like, Datadog is here today, and, like, companies like New Relic, they kind of take the base logging and make it a little easier. So in my experience, they do better than the actual services. The services will, like, provide every line of logging that you put in there, but they just won't actually tell you it'll do the logging, but it won't help you with observability. So it's kind of like just being very thoughtful of, when this app is running, this is what I want to know is happening, and making sure that goes into the logs, and then you can find it later. Like, say I have a service that calls out at once an hour work, you should have something that checks if it's not working once an hour. And then if somebody, tries to do something, you should have those audit logs so you can go back and see, oh, someone outside was hitting my API because I forgot to turn on an API key. So. Yeah, that's a great question. So the question was about containers versus service. It all depends on what your service does. So I use the Amazon e-commerce, like that was a good example, but it was only because I was shopping, and I was like, oh, I could just take a screenshot. It's actually a bad example, because Amazon has to be up all the time, right? It has millions of users. So if you have a site that's constantly getting hit, and the service always has to be up, it's not as useful. But if you have chunks of your service that only happens every once in a while, that's where Lambda works. Like, a great example of something I use in production is that I had to rotate a key, like, once a month. Like, there's no reason of putting that container and just having that running all the time. It only had to run once a month. And then there were other things where I was like, well, right now I have, like, 5 users, so my service isn't getting hit that often. But when it does, it might expand so much that that container's gonna, like, I might not have the machines I need for that. So it's kind of like both ends of the spectrum, where it's like, if something's running infrequently, serverless is great, or if something needs to scale up extremely quickly. So, like, if I need 1,000 machines for, like, an hour, and then only, like, 5, it's a great way to use it. But if you have something that has regular traffic, it's more trouble than it's worth. Anything else? Yeah. Yeah. So he was asking about how to transfer a huge on-prem legacy system to the cloud. And you mentioned a little bit, which is, like, right on the nose, right? So you want to think about either, is there any new features that people want and that hasn't already been built, and you can isolate that? For example, like the one I was talking about, I was like, I needed to rotate a key. That was the one I convinced them to put on serverless, because it was new, and it wasn't getting hit that often, and we could just try it out, and if it all messed up, it wouldn't be a big deal, because I had, like, 15 more days to rotate that key, right? So you want to pick something that's not business critical, and something that you can, like, pull off, by itself, and always never like let go of your legacy system. Like leave that going so that you can roll back quickly, because this is going to be all new, right? And then you would talk to it through. So if you have a bunch of services in AWS or any of the cloud providers, they can all talk to each other. But if you need it outside, that's where you would use an API, right? So if there's a way of putting in your legacy system just curl commands or shelling out the curls, like the easiest way to do that, where it can talk to the other API. That's one way of having talked to each other, but just like very slowly, one service at a time, and just seeing how it goes and using non-critical systems and see if you can talk to each other. Does that help? Okay. Anything else? No one else is in here, so we can keep chatting, or everyone can enjoy their lunch. Okay. Thank you.